So we're doing 11.4a today, and then 11.4b we'll do tomorrow, and then you guys are going to have a quiz just over 11.4, which is probably the easiest quiz you've ever taken. It is 2 questions. It's the volume of a prism and the volume of a cylinder, and that's all you have to do. So very short, leading into spring break, keep it simple, hopefully. And then so volume of a prism. Some of you may know a formula for this already. Anyone think that they do? Volume. I know you've learned one. It has 3 letters. What? Length times width times height. Is that what you said, Valor? I couldn't hear. So essentially, yes, length times width times height, that works for some prisms. The only issue is it doesn't work for every prism. So we're going to simplify it to a shorter formula that works for all prisms. But if it's a rectangular prism, you can do length times width times height, okay? Before we get into working that out, what is volume? It's not the area. The matter, the inside, right? What makes it up, okay? So it's the space that a figure occupies. That's volume. So far we've been doing area. That's like the outside surfaces, right, is our surface area. Now we're doing volume. So within that surface area, what can you put inside that figure, okay? Volume, so we're going to do this formula. What does B stand for? Area of the base, and H is the height of the figure. Okay, so at times it's going to feel like you're doing base times height, which is length times width times height. But I will show you a few examples and make sure you're good on that. What I need to know is, how do you do the units for volume? You cube it, right? So it's inches cubed, or feet cubed, or centimeters cubed, and so on and so forth. Okay, so make sure with volume that you're cubing it. With area, you're squaring it, and that goes for lateral area and surface area. Some of you on the quiz did lateral area was centimeters and surface area was centimeters squared. If it is area, it's squared, right? Because you're doing 2 dimensions there. So centimeters times centimeters is centimeters squared. With volume, there's 3, length times width times height. All 3 of those multiplied together would cube it, okay? So just keep that in mind as we go. There's a real quick principle. I'm not even going to write it down. I just want you to understand what it is. This guy called Cavalieri, big name, came up with this principle that just says if you have a figure with, let me just try to draw you a picture here. So let's say, don't even try and draw this because I don't know if this is even going to turn out like what I want it to look like right now. But you have a 3, yeah, no, I don't want those. I take it back. Let's say you have a 3-dimensional figure that looks like this, okay? The book gives it as an example, a stack of Post-it notes, okay? Let's say there's 100 Post-it notes in this little stack right here. So this is just Post-it notes all piled up. If I took those Post-it notes and I just kind of leaned them over a little bit. So now it went more like this. Oops. It's really hard to draw. Sorry. It just kind of tilted. Did the number of Post-it notes change? Did my volume change? No, okay? Cavalieri came up with this principle that says as long as the height is the same and the area of the base is the same, the volume is going to be the same, okay? So as long as you kept all the same Post-it notes, right, that bottom Post-it note has the same area and the height of it is the same. Yes, it tilted over a little bit, but it's still 100 Post-it notes tall. Okay, so that's what Cavalieri's principle says. We don't really do much with it, but I just want you to be familiar with it in case you see it in the homework. What we're going to do is more finding the volume of different figures. So our first example, I'm going to give you a rectangular prism. Are we getting better at drawing these things now? somewhat, maybe. Let's say this is 12 millimeters, 5 millimeters. I didn't draw this to scale, sorry, and 6 millimeters. You have to pretend it's a little taller, I guess. So if you have this rectangular prism and I say find the volume, we know we're going to use that volume formula, which is B times H. And we said B represents what? Area of the base, okay? Now here's the tricky thing, or can be a tricky thing about a rectangular prism. You don't have one set of bases. You could have technically 3 different sets of bases. It's just which one you want to use. So parallel and congruent rectangles here, parallel and congruent rectangles here, parallel and congruent rectangles here. So pick which one's going to be your base. I recommend when it's a rectangular prism just using the bottom because that's what most people tend to think is the base anyway, but you don't have to. You could use any side as your base. Then you should be careful about what your height is, okay? So I'm going to use the bottom. So let's say this is my base. What is B then? 12 times 5, right? That's a rectangle. The area of the rectangle would be 12 times 5. So that's B. What's H? The 6. The distance between the two bases, okay? So this is your H. So you are doing, for the volume, 60 times 6. So your volume works out to 360. And how am I going to label it? Cubic millimeters, or millimeters cubed. Okay. Questions on that? So this is the one that it's length times width times height, right? If it's a rectangular prism, you're just multiplying those 3 numbers, 12 times 5 times 6, in any order, because the order is not going to change anything. Where it's a little bit different is if your base is no longer a rectangle. So let's say you have a triangular prism instead. This is 22 inches. This is 8 inches and 15 inches. What is your base? It's the triangle, okay? And a lot of people see this problem and they think the base is 8 times 22 because there's a rectangle there, right? But you don't have a parallel congruent face to that 8 by 22 rectangle. So that is not your base, okay? The base is always the 2 that are parallel and congruent. So it's the 2 triangles on the sides right now. So if we're going to do the volume equals the area of the base times the height, what is the area of your base right now? 15 times 8. What else? Times a half, or divided by 2, right? So it's a triangle, so you have to do 1/2 base times height. So you're going to go 1/2 BH for that B, which is going to be 1/2 times 8 times 15. Okay, so that is B, area of your base. Let's just plug that in real quick and give you a number. 1/2 times 8 times 15 is 60. Okay, so your volume is 60 times H. What is H? That's the 22, right? So it's the distance between the 2 triangles. So this one is your H. So that's 22. So you do 60 times 22, and that comes out to 1,320. And then you label it inches cubed. Okay, so just make sure when you see that capital B, don't just assume it's a rectangle and do base times height. It might be a triangle, 1/2 base times height. It might be a hexagon. If it's a hexagon, you're going to do 1/2 AP. Yeah.
Didn't you still get the record
Doing what? Using the rectangle?
multiplying all those things and then like dividing by 2, like
If you did 15 times 8 times 22,
Any order.
what? In any order?
No, I'm saying.
You're saying do 15 times 8 times 22 and then cut it in half, right?
Yeah.
Yes. Why do you get the same answer? You can. Think about a rectangle versus a triangle, right? So a rectangular prism, which is length times width times height, compared to a triangular prism, which is half of a rectangular prism, right? So you do still get the same answer. And if you think of it that way, great. You can totally do it that way. That'll work for the triangular prism. It won't work for like the hexagonal or all the other ones, but yes, you could do it that way on that problem. Where you're gonna see differently is the one I'm gonna do right now. You won't be able to do that with. And it is a triangular prism, but it's not a right triangular prism, so that makes a difference. It's a good observation, though. Okay, last problem. This one's a little fancier. Still a triangular prism, but not a right triangle anymore. Let's say this is 8 inches, 8 inches, 8 inches, and 10 inches. All right, so for this one, we know the formula is area of the base times the height. What is your base? What?
8 times 8.
Not 8 times 8. What shape is your base?
The triangle.
It's the triangle, right? The parallel and congruent would be the two triangles. We have to find the area of that triangle. What do you do? What?
So it'd be that. So 8 times 8 times a half, right? Or no?
No, because 8 and 8 are not your base and height, right? You got to draw the height in and then use what? What? You can do Pythagorean theorem or special right triangles. You got a couple options here. I would do special right triangles just to keep it in simplest radical. So if I just look at my base right now, okay? We know these are all 8, which makes that what kind of triangle? Equilateral. What are the angle measures in an equilateral triangle? 60. So that means this is a 60-degree angle. If I'm going to use this as my base and I draw in my height, that makes this 90. Now what kind of triangle are we looking at? A 30, 60, 90. Okay, so this is 30. What would this be? That's 4. It's half that side, right? So this is 4, which makes the height, what? 4 rad 3 in a 30, 60, 90. Okay, now you can find the area of that triangle. What is the area of that triangle going to be? What's B? If we're doing 1/2 base times height, that's going to be 1/2 times what? What's B? B is the 8. What's H? 4 rad 3. Okay, so this right here is B. That's the base, that's the area of the base of your figure. What is H in our initial formula? This H. 10. It's the height of the figure, which is the distance between the two bases up here. That's the 10. So that's going to be your H. Now here's where this one can be a little confusing for people because they're like, wait, I thought H was 4 rad 3, but now you're telling me that H is 10. It's two different H's, right? The one is the height of the triangle. The other one is the height of the three-dimensional figure. So just make sure you're keeping that straight and you'll be in good shape. Okay, so this is base. times height, and if you multiply that out, so 1/2 times 8 times 4 times 10, leave the rad 3 out for now, you get 160. And then you can attach the rad 3, and then it's inches cubed. Okay, if they say round to the nearest tenth, then you would just plug the whole thing in 1/2 times 8 times 4 times rad 3 times 10. And if you had to round it, this would be approximately 277.1 cubic inches. Okay, so finding the volume, just be careful with your H's because there are 2 different H's oftentimes, and you got to make sure which one's which. But that's what you're doing for today. Questions on any of that? All right.